Hello everyone and welcome in this video lecture. My name is Manolis Fragiatakis and I'm a PhD student at Leiden University. In this video, I will show you how to run the manual activation classifier that I have developed. The goal of this classifier is to predict when a person is moving his or her hands in a form of a sign or a gesture and create annotation slots automatically in an ELAN file that we can later on annotate with a proper meaning or gloss. In this video lecture, I will explain what pose estimation is, what Google Colab is and how we use it, how to use the classifier that I have trained, and how to retrain it if necessary. Now, how we can do that? We first need to recognize where a person is in the video and extract the locations of the hands and torso, etc. To do that, we will use a framework that's called OpenPose. This framework can detect multiple people in a video and extract the locations of the body, the fingers, and the face, like in the small video on the side. When this is done, we pass these locations into a machine learning model that I have already trained. And with this model, we can predict whether a pose belongs to a signing or a not signing sequence and pose. I will show you how to do that and also how to retrain that model in case it doesn't work in your data. Now, all of this process will happen in Google Colab. This is an environment created by Google to run Python code in their servers. I chose this environment because it doesn't require any installation and it runs on the cloud. And also it is quite fast because it supports GPUs. You have to keep in mind that Google allows you to run this environment for 6 hours straight every 24 hours. This means that after these 6 hours, all the data you have uploaded will be deleted. So without further ado, we can just click on this link. I will also have a link to this environment in this video description. And you will be redirected in an environment like this. It's more likely that you will see something like this, where there will be a button open in Playground. What you have to do, or what I am suggesting to do, is click here where it says File and save a copy in Drive. This will save a copy of this Google environment in your own Google Drive, so you can access it whenever you want. It is possible that you might get a warning that this is not an official Google Colab environment, and there will be a button where it says Run Anyway, and you should be good to go. I won't do that because I already have this environment in my Google Drive, and this is what you will see. I have organized this environment with steps that you can follow, and in case something gets wrong, you can always trace in which step something got wrong, actually. The first thing that I have to tell you is that all these cells, is what they called, contain code that I have already written for you. If you, for example, double click in any of these cells, you will see all this code. You don't have to change anything. Also, in case you just accidentally double click, you can just double click again in an empty space and the code will go away. The first step we have to do is make sure that we are running on GPUs, because this is a requirement for OpenPose to run in Google Colab. To do that, you just click here where it says Runtime and change runtime type. As you can see here, where it says Hardware Accelerator, GPUs are already selected. If that's the case, just cancel it, or you can actually click again GPU and save. You can click here where it says connect. This is optional because as soon as you click in any cell and make it run, it will automatically connect with Google server. Now, the first thing that we need to do is install OpenPose in this environment. We do that by clicking in this play button, and you will see that in a while some code will start appearing. You don't have to do anything for that. It will run all by itself. As you can see, there is a circle running around this. Now it's a stop button. You have to keep in mind that this step will take some time depending on your internet connection. Approximately, we'll need 5 to 10, maybe 15 minutes to install OpenPose. You can also tell that something is running in Google Colab, either by looking at this figure, or up here, you see that the color of this icon is gray. That means that something is running. Yellow means that everything is fine. And of course, if you get a red color, it means that something got wrong. You see here, there are these things appearing. It's perfectly normal. Once finished, this will be returned to a play button and you will be ready to continue. Okay, so after some time, the installation has finished, and you can verify that because this icon has turned back to a play button and this color is now yellow. We can move now to the second step, where you can either upload your own video or you can select a video from YouTube. To do the second step on a YouTube video, you just need to select any kind of video you want and just copy this part from the URL. It's after the watch v equal and then this part, and you paste it here. You can also select how many seconds you want from the whole video. I would advise you to keep it basically less than 2 minutes. For this example, I'll just run the classifier in a video that I already have. You can see as soon as you click this icon, there is this choose files button, and from there you can just select the clip video you want, and it will upload it in Google Colab. In case you are working with a different browser rather than Google Chrome, you can just click on this files icon, and here you will see all the files that we have installed right now in Google Colab. You can just click here, upload, and you can just upload your own file. When you're done, you just click the X button and it goes away. So you can see here that I have uploaded my video. Now on the third step, I need to select the type of the video I have uploaded. If you're using, again, a YouTube video, just put MP4. It is also the case for the video I have uploaded, so I just leave it MP4. You can just put whatever video type you have. It can be MOV or MPEG, doesn't matter. In this case, we have an MP4 video, and then you click the play button. It will take a few seconds and it has already finished. So now in step 4, we'll just run OpenPose in the video. This will take some time depending on the length of your video. I will just click it here and just wait a few minutes. It will say that it cannot remove but this file, but that's okay. It's not for our purposes. So after some time, the cell has finished running, and you can see here the output. Just scroll down and you can just run the next step, which is to actually view the result and see how OpenPose found the body joints in the video. If you are using a video from YouTube, just put here test_video. In my case, I have uploaded my own video, so I'll just put the name of that video. You don't have to put the extension of that, and you just click the play button. This will take some seconds to render the output, and you can click here and actually view the result. As you can see, we predicted where the body joints are, and in some cases the finger joints, but because of the quality of this particular video, it didn't predict the fingers very well. But that's okay, we don't use these joints in the classifier. Now, the next cell is an optional one. I will show you later on how to use that one. It's actually only used when you want to upload your own model, but I will show you in a while. So we move to step 6, where we click and we wait till all the models have been loaded. And in step 7, we can run our predictions. Here, there are a few modes that you can select. I have already trained some models on different kind of data, and you can actually play around with that. I will, for this example, I will select the random forest model to see how well it predicts whether the frames that I have in my video belong to signing sequence or not. Just click that and you wait a few seconds. You see it will tell you how many people there are in the video and how many JSON files. These are files that belong to the output of OpenPose. Essentially, it refers to how many frames you have in your video. In the next step, you can actually view the times, or actually the frames, that belong to signing sequences. And it's a step where you can actually verify if the model that you have selected in step 7 worked or not. It can work also in videos where you have multiple people, in this case 2 people, but in my video I only have 1, so I will just leave it as the title says, in 0, and I will just click the play button. Here you see the output, and this is actually a list of the frames that belong to a signing sequence. Now, I know that in my video there are multiple sequences that belong to signing sequences, and this is for sure not just one signing sequence, but there are multiple. So I will go back to step 7. I will select a different model, and I will run again the step, and I will click again in step 8. Again, you see the output is not the correct one, so just play around. I can just select the neural network in this time, run again the 2 cells. Here you can see it predicted 2 different signing sequences. So based on my data, I will select this model, which is called debug XGBoost, and run again. And now you can see there are more sequences recognized as signing sequences, and this should be the correct output. I will explain later on what happens if none of these models or modes predict well your signing sequences. These numbers refer to frames. So each line refers to from which frame till which frame you have the signing sequence. So in this example, from the 75th till the 244th frame, there is sign, and so on, so forth. In the step 9, we'll install a library that's called PyMPI that will allow us to create annotations and create an ELAN file automatically. So we just click on that and wait a few seconds. It will install the library in Google Colab. And we can now move to step 10 to actually create the annotations. Here I have some information that you will have to fill in. You have to select the author name. In this case, I'll just have my name. Then you can select the name of the tier you want to add the annotations. This will be a new tier, so you can name it as you want. I'll just name it here as tier. Next, you can select the activation gloss. So what kind of gloss you want each annotation to have for each signing sequence. I can put it as just signing, or if you want, you can just put a space and just leave it as that, and it will create empty annotation slots in your video. I'll just put it as signing for now. The next variable is quite an important one. Here, you have to select a number based on the length and the frame rate of your video. You see it goes from almost 0 till 60. If the annotation slots are not properly aligned with your video, that means that you have to change this factor. It can be, for example, that the annotation slots exceed the length of the video, or they are really cramped in the beginning of the video. That means that they need to be stretched. And this is a variable that depends, again, on the length of your video and the frame rate of your video. So feel free to experiment with this. In my case, I know that it's approximately 30 seconds and 29 frames per second as a frame rate. So I will leave it at 30 as this number suggests. Next, you need to name the ELAN file you will create. I'll just put clip_test. And you can actually now run this cell. You will see ELAN file created. And now you can just click on the last step and download the files. This will zip all the necessary files, so the ELAN file and the video, and it will download it in your computer. You can just extract the zip file and go to your downloads. It should be a file named content, and it will have the ELAN file and an OpenPose folder that contains the rendered clip with OpenPose. So you can just double click on the ELAN file. It will ask you to select the video, and here you can see the annotation slots the model predicted and the gloss I put earlier in Google Colab. Now, if the alignment factor was wrong, you might see, for example, annotations in this side of the video, that means that you have to put the factor less than 30, or if all the annotations are cramped in the very beginning, that means that you need to drag it towards the end of the line. I will close this and get back to the Colab environment. The last step, it's an option one. If you want to rerun OpenPose in a new video, for example, and you are still in these 6 hours that I've mentioned earlier, you can just click and this will delete all the files you have uploaded. You don't have to reinstall, as you can see in the step one, you don't have to reinstall OpenPose. But again, you will have to upload your video. So this is what will happen if everything went perfect. The alignment factor was correct. The model you selected actually predicted the signing sequences. But again, you might work with different data, with different videos. So it is possible that none of these models worked well in your data. So how can you retrain these models? I've created another Colab environment, which I've named Retrain Manual Activation Classifier. And in this environment, I've put steps on how to run each cell. And in this environment, we will retrain, or we will train a model specifically for your own data. So again, just follow the steps. First, you need to install OpenPose and or the necessary libraries. This is the warning that I mentioned in the beginning of this video, that this Google Colab environment was not authored by Google. It's okay, just click run anyway, and you should be good to go. So now you have to wait a few minutes to install OpenPose. So after some time, the installation has finished and OpenPose has been installed in this new environment. So we need to proceed with the training of the model. Now, typically, in order to train a machine learning model, you need to create a dataset containing videos, in our case, of only signing and videos of not signing, and then proceed to actually train the model. Now, this can be a tedious work, and you might not have the proper video editing tool to split your own video in smaller sections. So I have structured this environment in such a way where you can actually upload a video with its annotation file, and then the cells will actually extract the subclips. So what I mean by that is that you have to go to your video that you want to train the classifier, and go and add glosses where you have signing and when you have not signing. In my case, I just went in the same video as I showed you earlier, and I just glossed signing and not signing. You have to be consistent with your glosses. You should not have signing 1 and signing 2. They should all be the same. And you should not have space between the words. So a gloss, for example, that is like this, so not space signing, is not acceptable by the environment, so you should gloss like that. Once you've done that, this should be approximately 3 to 4 minutes of video time. It doesn't matter if it's in the beginning of the video or at the end or in the middle, just anywhere in your own video, just go and annotate signing and not signing sequences. Save that elan file along with the video, and you can proceed now to the next step, which should be this one. So again, if you're working with Google Drive, you can with Google Chrome, you can just click in step 2 to upload your video. In this case, I'm working with a different browser, so this step will show an error. It's okay. I can just click in this files icon, click upload, and I can just go and select the MP4 file that I have, so my video, and the annotation file, which is .ef extension, and you will get a warning, that's fine, and this will go and upload, as you can see here, the two files that I want to use in this example. If you do this, you don't have to run step 2 and 3, so you can just now proceed to step 4. Here you just need to run this cell, and this will import some functions that I have created that will extract the subclips. So here you can go to step 5, and you will select the annotations you put earlier as signing and not signing. In my case, you can see here, I have signing and not signing with capital letters. So I select these, and the format of the video I have uploaded, in this case, is an MP4 file. So you will go and run this cell. This is also quite useful for people who just want to extract small video clips from their videos. As you can see, this was quite fast, and you can actually verify which clips have been extracted. You can just go to this files icon, expand the OpenPose folder, and here you see two folders with the name of the glosses I have, and inside are all the sub clips of these annotations, and this is for signing and not signing. Again, if you have a different gloss for signing, this name will be different, and of course the same for not signing. So now that we extracted our sets of videos that we want to use to train our model, we need to run step 6, which will run OpenPose in these videos. This will take some time, of course, depending on the number of glosses you have in your video. So a few minutes later, OpenPose has finished, and we can proceed with step 7 to actually create a dataset. This step takes all the outputs from OpenPose and arrange them in a proper way to train our model. And we can actually click now step 8 to train our model. This will produce a graph like this, and here where it says AUC, it will show you how accurate your model is. In this case, it's 98% accurate. which is quite good. If you get a number lower than 0.8, that means that you haven't glossed enough data. So I would suggest go back to your video and annotate a few more examples. Again, they have to be both signing sequences and not signing sequences. And the last step, you just download your model. It will ask you if you allow to download, and you should be good to go. This will contain a file which will have the extension of .sav. It's this one. And you will keep that file, so you will use it in the other Google Colab environment, which I will show you right now. So you will go back to your to the original manual activation classifier environment, and you will go to this step where you can actually upload your model. You will run this cell. If you are working with again with a different browser, you can just go here to the files icon, click upload, go to your downloads and select the mymodel.sav file. And this will go and upload your file. So now you just go to step 7 and you select your own model. And this will run the classifier with the model you have just trained. And you will verify again the signing sequences in step 8. And you will proceed again with the next steps. So step 10, you can omit step 9 since you have already uploaded, you have already imported the PyMPI library. You will run step 10 and step 11 to download the files. Again, if the alignment factor is correct, you can just come back, change it, rerun the cell, and re-download the files, so you will have the newer version of the ELAN file. This concludes how you can use the manual activation classifier with your own model, one that has been trained for your own data. And I hope that everything was relatively clear. I will have all the links in the description below, along with some timestamps, so you can easily navigate in this video. If you have any questions or suggestions, feel free to send me an email in this address you see on the left. I will leave also the comment section below this video open. So if, again, you want to ask a question, you can write it down there. I will keep working on this Colab environment. So maybe in the future, you would see some things that they are a bit different. I will always have some description above each cell. And that's it. Thank you very much.